Testing, testing. There we go. Okay. All right, I'm running a little behind. Wanted to make sure I had everything ready. Oh my gosh. Okay. Okay. I want to talk to y'all about what made you feel like the exam was hard, because I was kind of surprised to find. What do you mean? I told you. I was kind of surprised to find a lot of students responded to the document by saying this exam was harder than they expected compared to the last one. And I do think there was a combination of reasons for that. And I'm going to tell you what things I think happened with that after reading all y'all's results and looking back over things. But first, I want to start by hearing what y'all think made it hard. And I'm going to make notes of this on a document so that I can remember. And I know this is kind of scary, it's vulnerable, but if you looked at the breakdown, a lot of people had like 8 of the class, 8 out of 45 people who responded said they had exam concerns, and another like 8 said that they were feeling just completely lost and overwhelmed. Only like 15 felt confident fully. There were some that felt confident and they were still scared. They're like confident, but I'm scared of what's going to happen, right? So you're not, even the most confident students had caveats. So if you're scared to say what made it feel hard, just don't be, because other people are thinking it. You're just the only brave enough one to say it. Yeah.
On the last one, I felt like the practice test was really similar to the actual test. And on this exam, I felt like there was a different amount of multiple choice questions on the practice test. And then I know on the regular test, like the written portion was a lot different than anything we've done, like drawing the answers. I felt like I didn't get enough practice with that.
Okay, that's good to know. I'm going to talk about, I think I lightly disagree that the free response was different than other things you've done. I think it was just put in a slightly different way and it caused people to freak out a little bit. That's part of test taking techniques that I think I want to talk about. And after I looked at it, I was like, oh, I bet that happened, is that they didn't recognize it as being as similar. I do agree that the practice test was not as similar. Part of that is because I don't make practice tests just to prepare. I like pull from old exams that I've already given. And the summer schedule and the regular class schedule are so different. So because those two are so different, I think it made it to where, like, actually when I gave them their second test, it was over. They'd already done chapter 4 in the first one, and their second test was over 5 and 6 and part of 7, right? So their test was a lot more comprehensive. So I actually had to ask different harder questions, or like, different things that were beyond what we've covered. And so it was hard for me to get together a practice test that was as similar. But to make the exam, just so you guys know what I did, is I took that practice exam and I edited some of those questions, and then I just added enough to get it to the right number. So I did try to make it as similar as I could, but I can see how that was different. And so I do think I want you guys in the future not to rely fully on the practice test. I almost didn't even put one up because I didn't want that to happen, but it was requested. And so I tried to give it the caveat. So that might be something to keep in your mind for future exams, is that it's not the exact same as the practice. It'll be similar because I pull the test bank from the same questions and I make the exam. So it's like still from my brain, but it's not ever going to probably be exactly the same because it's not from a previous summer semester. Now, my next summer semester would have the advantage, right? Because I will be able to give them your exams. But I haven't done a summer semester before, so I think that makes it harder. Okay, that was good feedback. What else made this test feel harder? Yeah. I think that is part of summer classes being freaking crazy, which sucks. Like, there was a teacher here who's a conscientious objector to summer ochem, and they refuse to teach ochem in summer because they think it's too fast paced to actually learn the material. So I don't think you're alone in that. I think there are a lot of people who feel like it's just so fast paced. And I think that's part of why at the beginning of the semester, I was like, I hate to say this, but I think we might need to just clear our schedules for 5 weeks. Me too. I work all the time. My husband's like, hey, you graduated. I thought you weren't going to work all the time. And I was like, hey, 5 weeks hit me like a ton of bricks. Okay. I'll be normal again in, well, like 3 weeks now. But yes, so I think it's been just like kind of a crazy pace. And so I don't think you need to feel too bad about that. I think it's just if you can clear your schedule and devote a little bit more time, that might be helpful. And then also, I think the first week we did 3 chapters, right? But last week we only did 2. This week, I think we're only going to be doing 1.5. So the pace is slowing down some too as we move through it. But I definitely understand that feeling. I don't know how to alleviate it other than what we're doing today, which is like slowing down a little bit and debriefing. Yes.
I thought with the first exam, I feel like both the practice exams were pretty, at least on the multiple choice, I felt like it was pretty reflective on both of it in terms of like concepts and what it should be studying. But I felt like on the free response, with compared to like you said, the practice exam is not
right.
Like could be the exact same. But on the free response, I felt like we didn't have as much practice in drawing the confirmations from on big pictures from visual directions to bond line and bond line.
Yeah. Converting between the different ones.
Yeah, the vote and share structures, and then also like the different trends. That's what got me was the differences on the confirmation, trying to draw it out.
On the chair one or the Newman one? The chair one. Okay. Yeah.
I felt like there wasn't as many questions that where we had to draw it out like that, and so
Yeah.
I wasn't so when I saw that on the exam,
You were surprised.
Yeah.
Okay. That's good to know. I wonder if something that would help is I hesitate to give you too many practice problems, right? Because there's already so much material. that sometimes I feel like if I give extra practice problems, it's just overwhelming, right? But maybe since you already have a lot of practice problems like the multiple choice, I could give you more practice problems like the free response. And then I also think I'll show you kind of where I get the free response questions from, and I think that's going to help you too. I also think what happens in normal semesters is we have more time between quizzes and tests. So my quizzes reflect the free response, and then the homework reflects the multiple choice, right? You guys get one quiz, and it's usually only on one chapter. And then we have another quiz, like another chapter that you've never seen quiz questions on. And I think that kind of puts you at a disadvantage compared to my normal semester. So I wonder if maybe like doing more practice quizzes or like that kind of questions for you without overwhelming you too much, but giving you more practice.
I
Yes.
was gonna say, going off of that, I think you give us a lot of really good practice problems, but personally for me, if something isn't like a grade or I'm not preparing for a test, I usually am not motivated to do it during the week.
Yeah.
Especially because I'm in other classes and I know a lot of people are in the lab as well. So I think if something isn't like to turn in or I'm not preparing directly for the exam or the quiz, I'm not as motivated to do it.
That's a good question. So, and I thought about this with the quiz this week. So it's hard because the quiz is on Wednesday. I did that on purpose so that you'd have some accountability to study on Wednesday. And if I put it on Thursday, it's the day before your exam. So it sucks to have a quiz and then an exam. But would you rather have the quiz online format the way that I did it this time? And it's due Thursday and then it covers more of the material, or would you rather have more practice problems? Thoughts? Yes.
Online quiz might work if we can still get feedback.
I do. I mean, it'd be a faster turnaround, but I do give comments on online quizzes.
I would struggle like virtual, like I need a paper in front of me to be able to actually understand what I'm doing.
What if it was an in-person quiz on Thursday? Okay. But then how would I give you your feedback before your exam? This is how I struggle to set up your your class. Yes. Yeah, if I did a quiz on Thursday, I'd be able to cover almost everything that we done. You'd only have like half a class left before your exam, so you'd get more questions similar to what the exam would be like. So I'm open to changing it, but I just don't want to change it in a way that makes it worse. Yes. That's true. The quiz being online does give me more time to teach and y'all more time to do practice problems where I'm here and you can ask questions.
I feel like the teacher, like that. So like we don't have problems here on the quiz, and for me, like the quiz doesn't make me accountable. I don't know. Send an email that will to get a file.
That's true. If you have file uploads, you could do it on your own paper. There's a question or thought down here.
With my response to last semester, we actually I kind of like that format because it's like right now recitation can be more like fresh because we have so many problems with the recitation jacket, and like once it's we maybe we can longer we have to done, and then like I go home and you know, honestly do the rest of it because I don't know.
That's a good insight. I think I'm going to show you where I get my exam questions from after I hear y'all's two thoughts, and then Abby, I'm going to save you for just a minute. I guess I'll get all three of y'all. And then I'm going to show you where I get my exam free response questions from, because I think that might help you study better. Angel?
If we do this online and we have to go, it would be a lot more time.
Yeah, I could make it like 30 minutes instead of 25, I guess. I don't want you to be able to Google. And I use the honor system on that. I want you to use your own brain. I don't want you to cheat. You can use your notes anyway, but I don't want you to be Googling.
Maybe people we have two notifications, like the first one, the notification, and the second one. You could get like pre-response and they show like responses
That's part of why I do the videos, so I don't have to take time with me solving it, because it does, I used to do that actually, and then a study came out that showed that if students tried it on their own first and then they went and watched someone solve it, it works way better for their long-term memory. So I don't take up class time doing that, which sucks because it puts more on y'all, but that's part of why I changed that. And then Abby, your hand was up for a while.
I just have two things kind of accumulated over,
Okay,
talking, so for the exam, for me, it was more the time crunch. I don't know if anyone else like struggled with that.
other
but
people did.
The time felt like super crunched in. I think that's because the free response had like 3 or 4 parts to it. I can't remember.
Yes.
So there was that, and then I was thinking to add on to the free response thing you were talking about. Like, what if we just added on like 1 or 2 free responses to the homeworks? Because the homeworks really help me, and that way we can still keep the quiz and everything, and we don't have to worry about,
And you have accountability.
that's what.
I love that. That's a really good solution. Okay, so let me show you. Part of it is like, maybe I need to be less trusting you to do it on your own and do more accountability, because I would need that too as a student. But here are the free response questions, okay? I want to show you where they came from. So because I got the feedback that people were like, wait, where did these come from? Like, I'm so surprised these are totally different. This free response question is the exact same question as this multiple choice question. You just have to generate the answers yourself, which you should have been doing when you're practicing your multiple choice anyway. Like, when you're practicing your multiple choice, you should be able to generate your own solutions, if that makes sense. So that's something that I think maybe you could tweak that would help you prepare for the free response without adding any more questions, is if you're doing your multiple choice questions, you generate the answer and then check the A, B, C, D, E, F, G, whatever, and then see which one matches what you have. Because I think that will significantly help in the free response, because it's literally, these two are basically the same exact question. And I actually thought this is harder than generating your own, because all you have to do to make an enantiomer is take this molecule and draw the exact mirror image, and that's quick. And then to do a diastereomer, the top looks the same and the bottom is the mirror image, or vice versa. So I actually thought when I wrote that question that it was almost too easy. But I think y'all saw it and you were like, we've never done anything like this before. I've never drawn anything like this. I don't know what to do. I'm freaking out. So I think there's a disconnect there where it's like, I expected you to be sort of generating your own structures while you were doing your multiple choice. And this actually, I thought would be one step easier, because you didn't have to rotate anything anyone else already drew. And actually, I think it freaked you guys out a little bit. And you're like, we haven't seen this. And you didn't know where to go. Is that a correct assessment? Okay, so I think that's the thing, that we don't have to add any more. We don't have to do any extra problems, but you can better prepare for the free response by treating the multiple choice questions in a way that you're generating your answers first and then checking the letters to see which one reflects what you came up with. Does that make sense? Okay, so that's where I got that free response question from. I literally went to the multiple choice and I was like, yes, I'll just have them practice drawing and it'll be kind of an easier question. I do think this top one was the hardest part of this, though, is visualizing it in the sawhorse formation. That was the part I expected to be hard for y'all. Okay, that's good to know. You didn't know how to do that at all. Okay, when I'm grading, I'll give that lower probably points than the other ones. Okay. This question was the exact same as, I don't have it, but I have it here. This question was the exact same question, but with less work as the last question on the chapter 5 recitation. So this one was more complicated because it was like all these chains and the hydrogens weren't pointing back. And you also had to draw it out in bond line and then do the name. But all you had to do on this was draw the name. So, oh, you can't see it. So I literally took this question, took away this part of it, and just said, give the IUPAC name. So it was the exact same question as that, only I thought it was easier. Might not have been, but I thought it was like an easier version of that. Okay, and then the very last one, did Margaret just walk in? I might need to kick her out for a second. Okay, the very last one is actually the same as your test question where you had to draw a chair formation. And a lot of you were close but weren't perfect, so I wanted to test you on that again, drawing the chair formation. And the only thing I added was the drawing the R or the S. And I could see that being hard. But if you come up on a question like this on your free response, if you start here, drawing a chair conformation of this, you'll get points. And you already know how to do that and you're already tested on it. And then the only thing that I wanted you to add was being able to draw the RNS configuration. And I could see we did not do any practice problems like this, but we did some that weren't cyclohexane. We did them in chains. But I basically thought you'd be able to, just draw it flat and do fluoro and tert-butyl and then assign the priorities and be like, okay, that's R. And then we'll assume this is the wedge and this is H. So 1, 2, 3. That's S. And now I'm just going to convert this to the chair conformation. So I did talk about on the video that I made for the recitation that's how I always approach drawing R and S configuration, is I will just assume the substituent is a wedge and the hydrogen's pointing straight back so that it's like fast and easy. Assign the configuration that way. And then if I have to invert it, I will, or if it's right, then it's right. And so I actually made it on purpose to where the wedges would be right and you wouldn't have to do that extra step. So a lot of this came from, some of it came from your quiz, but a lot of it came from that recitation packet. So I think that insight that you're not taking the recitation packet home and doing it, that might be a key way to change preparing for the exam, is that the free response questions are a lot more like the recitation packet and then previous quizzes. And I'll try to upload all my previous quizzes, but again, after the first unit, it's not exactly the same. So you could look at those previous quizzes and try to use those as well as practice problems without me having to add any more. Okay. Does that help you to know how to prepare better for your exam, knowing where the free response comes from in general? Okay. So I'm going to go back to this list. Okay, so I think the solution for this, I agree. I'm going to add the homework free response. I'll probably put 2 homework free responses on, and I'm moving the homework back to be due Saturday. I had it due Friday, so you would have Saturday to review. But some people said that Saturday would really help, and I don't care when it's due. I want you to do it. I have it built in for accountability. So I think we'll do more homework like the free response. We'll keep the quiz in person Wednesday, except for this week. This week I am going to do it online because I am taking basically away the quiz time to do this debrief, and I think it's important. Okay, so the next thing I wanted, so we talked about the practice test, that it's not always going to be very similar. So don't prepare for the practice test to be like, oh, it's going to be I talked to my husband about this too, because I was like, how can I make this better? Don't prepare for the practice test as if it's going to be like the same exact questions with the numbers changed around. Use the practice test like, these are the concepts she's going to test us on. So what are other similar questions that have similar concepts? And it seems to me like y'all's multiple choice, you have more than enough, or quite a bit of multiple choice practice problems, but you just want more free response. So I'll add free response questions in, and I want you to use the recitation packets as well. And then I'll post old quizzes as well to help you prepare for the free response more. For the overwhelmed, too much to learn, there was about 8 people who said that. It's just a lot. It's just overwhelming. I know it is. I don't know how to solve that problem. I'm overwhelmed too. I decided to redo these freaking PowerPoints and I hate myself. It takes like 2 hours for every chapter, and we're doing a chapter every day or 2. Like, I agree that it's really overwhelming, and I don't, we can't slow down as much as we're slowing down today always, obviously, because we still have to get through quite a bit, but hopefully slowing down a little bit today will help some with that and getting chapter 5 more solid before we move forward. And for the time crunch on the exam, I think the best way to do that for you to feel more comfortable, I could give you like 5 more minutes, but I can't give you much more than that. And I actually I gave you like 52 minutes this time. I like rounded up and gave you a little bit of extra time. But I think a good way to help you prepare for that, part of why I don't want to cut it back is because Dr. Bear, he does the same thing. It's 50 minutes. He has usually like 24 multiple choice and 3 free response, but his free responses are shorter. So I've kind of put the emphasis more on the free response than he does, but like that's still 27 questions that you're getting through in 50 minutes. That's 2 minutes a question on average. And it's even more questions if he does the ACS final exam. So I am hesitant to improve your time or to like give you more time. What I would rather do to help prepare you is you guys use the practice test and the practice problems to see how fast you're going and then see if you can improve your time. So use the practice test. Like when I posted the practice test, I was like, there's only 9 multiple choice, so cut your time back, you know? And what I suggest you do, because there's 15 of each question for mine, I guess there's 17 multiple choice, and then 15 points also come from the free response, is figure out roughly how much time it takes you per multiple choice and try to get it down to where it's less than half the times. Like if you can get through the multiple choice in 23 minutes, and then you have 30 or 25, 27 minutes to do the free response, I think that will be helpful for you. And I'm going to talk about test taking techniques on how to get your time down. Yes. Nice. Okay, this is basically one of my first ones, so I like this. I'm going to say take test out of order. So if you take the test out of order, there's no reason to take a test in the order I give it to you, right? So what I actually do when I'm taking a test is I go through, I do a quick glance over at everything. And then the ones that are immediately obvious to me as like, this will be very easy to do, I do all those first in the multiple choice and the free response. So I do something different than what you do. I don't do the free response totally first because I'm afraid I'm going to run out of time. If I could see myself spending so much time on the free response that I don't have time for multiple choice. But I do all the easiest ones that I'm like, I feel very confident on these, multiple choice and free response first. And then I go back through and do the ones that I'll call medium. Like, I know how to do this, but it's not quick for me. It's going to take a little bit longer. And I do those for both the multiple choice and the free response. So if I was going through the exam on this question, I would have, oh, I'm not up here. On this question, I personally would have been like, oh, this one's quick and this one's quick. I'm going to draw these right now. I know how to do these, but it's going to take me a little bit longer. So I'm going to come back to A and D later. So I would answer the ones I can do really fast and then I would move on. And on this one, I'd probably be like, oh, that's a later one, but I can do this fast. So I'll do this one now. Or I know how to draw a chair conformation. I'll just draw a chair conformation with these 2 substituents, and then I'll come back to make sure they're RNS so I can get my partial credit. So thinking about it is like, how can I show everything I have learned instead of thinking about like, I need to do each question perfectly, I think can help. And so I go through as quickly as I can, and I'm like, okay, this one I can do fast. That one's going to take me more time. This one I can do fast. This one's going to take me more time. This one's going to take me more time. Oh, this one I can do quick. Oh, this is a lot of parts. I'm not even going to look at that yet. This one I can do quick. This one I can do quick. I'm not sure about this one. Like I literally do that on exams so that I find that and go. The other thing I'll do is if I'm getting overwhelmed, like as I'm going through and it feels like there's a lot of, these are hard, I'm going to do this later, is I just flip to the back of the multiple choice and start from the back and work forward. So don't feel beholden to take the test in order. That's one of my big test taking tips. What other test taking techniques do you guys have? Nobody? Yeah. Mark the ones you think you might have gotten wrong. I do that too, actually. Mark the unsure ones, I put a star by them. I'm like, oh, maybe. And then I come back and check myself. Another thing I do is I don't let myself change an answer unless I can prove that I'm absolutely right. Because sometimes I would change answers and then I would get that one wrong after I changed it and I had the right one initially. So I have a rule now that if I think I'm right initially and I don't know why I'm changing it, I won't change it. I have to write out the structure that proves to me that I'm wrong, and I usually do it twice because that would change so often. Any other test taking techniques? Bubble last. So what I do also with bubbling, because I have ADHD, so I'll get out of order really easily, is I actually I also bubble last, but I will go through and just do like a light mark, like if I were to say this one's A, this one's C, this one's B, and so that way it's just a tiny mark on the numbers. And then I can go back and fill the circle all the way in, but I've made sure that I kept in order. And as I'm going back through and actually bubbling, I can make sure it's right. So it's like, yep, that one is A, that one is B, you know, and then I make sure that I didn't get out of order, because a lot of times I do get out of order. And if you do that, where you just totally get out of order and you have to erase everything, just kind of ask me for a different Scantron. It's not worth it. Somebody else had an idea. I saw somebody else. Yes. Just move on. Do not waste time staring at a problem you don't know. While you're staring at that problem you don't know, there are so many questions that you do know just waiting for you to get to. But when I do get to a problem I don't know, and I've done all the easier ones first, I didn't write bubble last. I eliminate wrong answers as much as I can. So this one, I think this one was pretty confusing. I didn't realize why it was confusing until another student showed me it, and they were like, this is why I was confused. It's always before, there's only been one difference, and there's 3 differences here, and how do we pick? Because this is higher than this, but this is higher than that, right? And I didn't realize that that would be confusing for y'all. I think we had one more similar to this on the practice test, but with this, with the ring and everything, I was like, oh yeah, I do see how that would be hard. So there's a lot more going on there. So actually for this, I'm going to accept, I think, just if you knew that it was R or S, I'll give credit for that. But on this question, if you came up against that problem and you weren't sure, you can immediately increase your chances to 50-50 by saying, you know, it's not cis or trans and it is R or S. So instead of feeling like, oh no, I have no idea what I'm doing, feel like I just have to figure out if it's A or B, right? That's like a little bit easier, and you're increasing your chances of getting it right just by eliminating the ones you know are wrong. Or on this one, the question, and I made a mistake on here, the answer would be the same either way, but this is non-E, but I wrote non-ine, but either way, the hydrogenation would get the same answer. You can pretty much guarantee that non-ine is not going to be the answer when it was also the question, unless it's like a really tricky no reaction type question. So you could eliminate that. Non-E is what's drawn, so you could eliminate that too. And then if you just remember, like, oh, the double bonds are eliminated, it can't be cis or trans. So if you just know those things, you can get the right answer. So you can eliminate questions that you don't, or answer choices that you don't know, even if you don't, like if you couldn't generate the answer to this on your own, which I want you to be able to do that, you could still get the right answer, even not being able to generate the thing on your own, just by drawing on the little bits of information that you do know. Yes.
I think that
Either one of them got the same answer. Yeah, if it was non-ine with H2 and any metal, it will delete double and triple bonds. So the only difference would have been, this would have been a triple bond to start with, but it still ends up with 9 carbons. You're not adding anything other than hydrogens. So even if you did this, I realized afterwards I did make that error. Somebody pointed it out to me and I was like, oh crap, but people had already started taking the test. But either way, if you add H2 with metal to either of these, you're going to end up with non-ane. It just gets rid of those. So that's, you know, I see how that could be confusing, but Yeah. And you can ask me during exams about stuff like that. You would have gotten the same answer either one that you used, but you could still eliminate all those things, even, you know, if you looked at this or this, you can still pretty well eliminate these two just by knowing that there's no double bonds left. You could eliminate all those because you can't have cis and trans with no double bonds unless it's a ring, and you can't have non-ene or non-ine if you know it gets rid of double bonds. So if you just remember H2 and metal gets rid of double bonds, you can answer that question. Double and triple bonds. Okay. So that's another test taking technique I use, is I eliminate wrong answers when I start at something that I don't know what to do. What else? What else do you guys do while you're going through tests? Yeah.
On more of like difficult questions, I work through as much as I can and then move on. As like the first one.
Oh, you like start by writing down what you do know and then you move on? That's a good
If
idea.
I get stuck on something, I'm like, okay, next one.
Yeah, like work until you get stuck and then move on. And then you already have that work done.
But sometimes if I work through it, it helps me to get to the answer anyway.
Yes. Yeah. Like if you just can remember like one or two things as you're working, you're like, oh yeah. And I do think that's something that happens on exams is we freak out and we're like, I don't know any of this. So it's like, well, you do actually, you know a lot. It's just you don't know this immediately off the top of your head. So something I oftentimes will say to my students before they start the exam is you know more than you think you do. So when you get to a question that you're not sure about, you know more than you think you do. You don't know the answer to that question right off the top of your head, but you do know things, right? Like you've been in this class for 2.5 weeks. So use the things that you know to get to the right answer instead of freaking out. So I have a lot of test taking anxiety. So that happens to me a lot, where I will literally be like, I don't know. And I just like kind of panic and get in this loop. But if you can break the panic loop and say, I do know things. I don't know everything and I don't know the answer to this question, but I know things and I can get points for things, especially on free response. You can get points for things. Use that to your advantage. So that's something with the free response that I really want you guys to do is like, yeah, you were freaked out by the R and S on the chair confirmation. You haven't maybe done anything exactly like that. I was making you put it all together in this time setting. That could be stressful. But you have already been quizzed over how to draw a chair confirmation. So it's like, you know that. So you could get the majority of the points if you can just put the substituents in the right places on the chair confirmation, you know? So I want you to, instead of thinking of it as like how much you're in the deficit, try to think of it as how much you can show. How much of this question can I answer? That's why I put so much weight on free responses, because I can give so much partial credit for free response. And I do try to give really generous partial credit for free response because I want you to be given points for what you do know. So like knowing how to do a chair confirmation is a good step. If you can't do R&S with that yet, fine. You still know how to do the chair confirmation. That's 3.5 out of 5 or whatever, you know? So I want you to be able to have that mentality of showing what you know and not being like, I don't know so much. I think that will help with not only your test taking in this class, but in all classes. Okay. Any other thoughts on how to take tests well? Yes, Melissa. I like that. I would never read the question 3 times, but you know what I do is I read it twice and then I underline keywords. And you can see that a lot of times when I'm working practice problems. I wouldn't read it 3 times because I'd get bored and I have ADHD, not because that's good advice. So you kind of have to also know your brain to know which one of these you apply. I'd read it once and then I'd read it again. And then I would do the thing that I always do where I'm like, lower, higher pKa, what does that mean? Smaller, larger, okay, and I circle that and I write a word that makes a lot of sense to me. Rather than lower, higher, I cross it out, I write smaller, larger. Or when I was first learning R&S configuration, I could never remember like clockwise or counterclockwise. So I would like write, if it was like RS, I'd write like counterclockwise. That was before I learned the right and left at the top trick. But so those are little things you can do where you read the question, you underline keywords. I remember them making us do that in like, this is gonna age me, but whenever I took the tests where you had standardized tests at the end of the school year in Texas, it was called TOS. And for our TOS prep test, yeah, TOS and then tax and then whatever is now, is it STAR? There might be have been one in the middle, but we would have to like circle keywords in, like they made us do that as practice to learn how to take exams, which some schools don't teach that. This is like kind of going off on a rant about people who grow up in better school districts are more privileged and more prepared for college, because my school literally taught me test taking techniques in elementary school, and I've been using them my whole life. Some schools don't work to implement that, usually schools in lower income brackets. And then you get to college and you are behind the kids who went to those other schools and learned those things. So that's also part of why I like to take time to do test taking techniques, because I want everyone to have an equal shot of knowing how to work the exam well. And not only in this exam, but all standardized exams you take, you can take these principles and apply them. Okay, that's my inequity rant, inequity in the public education, and how standardized exams are propagate inequity. And the SAT and the GRE are crap. Okay. Another test taking technique I thought of is because I was talking about the SAT. On the SAT, if you get a question wrong, you get counted off. Not in this class. You don't get negative points for guessing the wrong answer, right? Like on the SAT, if you get it right, you get points, and if you don't answer, it's neutral. But if you do answer and it's wrong, it's negative. You don't get points counted off for guessing wrong. It drives me crazy when people leave things on bubbles. I'm like, just bubble something. Like you have a 20% chance of getting it right. Just bubble something. Or when they leave free response questions blank, I'm like, just write anything that you know related to this. Anything. I can give you partial credit. Anything. If I can give you 1 point, that's 3%. Okay? 1 point is 3%. You can go from a 60 to a 63. You can go from a 67 to a 70. If you just write one thing, and I can give you 1 point for making any kind of attempt and showing me you learned anything about organic chemistry. Unless it's totally off base, I can give you partial credit. So like, let me give you partial credit. Guess on questions you don't know. Like, don't phone it in. Just guess on those questions. Who cares? If you don't know anything and you're out of time, put B for all of them. I don't care what you do. Just do something. That drives me crazy. I'm like, I can't give partial credit for zeros. And it doesn't hurt you at all to guess. The worst that could happen is you get a 0. I think sometimes students don't guess also because they don't want to look stupid, but like, I don't care. I did bad in ochem the first time I took it. I'm not gonna think you're stupid. I'm gonna think you didn't have time to study because it's summer. Like, just do something. Okay, that's another rant. I'm gonna write just freaking guess on here. Any other thoughts on how to take tests well? Yeah. Yeah, you always get at least partial credit, right? And I think part of that is you're classifying it as BSing your way through. And I would, when I was in school, I'd classify it that way too, but it's not BSing your way through. It's taking what you know and trying to extrapolate the right answer that you didn't know right off the top of your head. So like, it feels maybe you're like, whatever, I'm just BSing this question, but actually it's like, whatever, I'm taking what I do know and actually trying to answer this question. That's what I want you to do. That's like answering your question in an exam, right? So I appreciate that, and I do want y'all to do that. And then I saw another hand go up. Yes.
Specifically for the last one that we took, I think I also have trouble remembering what direction R and S goes. So
Mhm.
when I immediately got the exam, I drew out the circle on the
Yes.
topic. I'm like, okay, this
Yes.
is for any time that I have an R.
Yeah, or there's like, I mixed up ester, I still do this, mix up ester and ether a lot. And so when I would get my exam, I would write ester and ether and write out what those functional groups look like or something like that. Any other thoughts? Okay, well, I think this was really helpful. I really wanted to spend time talking about this because I think it was a combination of maybe me not being clear about where your free response questions came from and how to prepare well for free response questions. And maybe I think on at least one of those questions, I didn't anticipate something that would be confusing to you, which sometimes I think is part of what happens when you have a teacher who's been teaching this a lot, and then students who have never done it before, right? Like do my best to anticipate what things look like from your perspective, but it's not always possible. And because that's not always possible, that is why I put bonus questions in. So there were 2 questions that I was like, oh, these are probably harder than I thought, but there are 2 extra questions. And those bonus questions can get you up an extra 6% on the multiple choice. And they can get you up if you turned in your, it was not part of the exam this time, but if you turned in your bonus exam question on Canvas, that gets you up an extra, it's actually like 6.67%. So rounding up, it gets you close to 14% increase on your exam. So there are going to sometimes be hard questions that maybe you weren't anticipating, partially because I misanticipated what you could do. You know what I mean? Like my perspective was slightly off, but that is why I build in so much extra credit to the exams and the course. So again, when you're freaking out and you're like, oh my gosh, there are 4 questions on this multiple choice that's only 17 that I'm getting wrong. It's basically like there's only 2 that you don't know, right? Because there's 2 freebies. So try to also think of how much almost 14% bonus points are added in. And usually the bonus questions are doable things that don't take, especially for the free response bonus, that don't take too much additional mind power, hopefully. I try to do them questions that will be easy to answer in a variety of ways. Okay, and then there's also other ways to get bonus. So if you're freaking out about your grade right now, or if you're concerned that that exam was hard and you're worried about the next one, just remember there's the Chemistry is for Everyone essay. I think that's worth, what was it, like 10% or 10 point? I think this is 10% added to your lowest exam grade, I think. And that's your lowest kept exam grade. So 1 will be dropped, and then you'll have 2, and the lowest of the 2 will be added for your Chemistry is for Everyone essay. So that's a significant increase as well. And then there's also, if you come to my office hours, you get 1 point on your final grade, like 89 to 90 on your final grade, a whole point on your final grade. So please come to my office hours. If you have come to office hours and you've forgotten, or if I've forgotten to upload it, please email me. Yeah, Angel? Might be 2. I don't know. Whatever the syllabus says. I checked the syllabus before I had grades. Could be 2 points on your final grade. Could take you from an 88 to a 90. So that's extra credit as well. You know, there's lots of extra credit points for you to get your grade up. So I don't want you to be worrying about your grade. I want you to be worrying about understanding the material well, and then going into the exam and showing me what you have learned instead of worrying about not having all the perfect right answers. And I do think this is like the organic chemistry teacher preacher mode, but practice, practice, practice. You know, it's like the more you practice, the more you'll recognize those types of questions, the faster you'll be able to draw those things, the quicker you'll be able to answer, the easier it will be to get through your exam. So easy for me to say because I've already taken it like 4 times and now I teach it, but yeah. Okay, I think that was everything I wanted to talk to you about on the exam. Did I miss anything? Are there any things you're feeling like bleh about? Okay, so you only have this week's quiz and next week's quiz. So this week's quiz, I'm going to keep it online. I'll make it a little bit longer than normal, and I will have it due later in the week because we've barely covered any material because we're doing this instead, and you'll only probably have 1 recitation this week. And I will add in, I need to remember to do this, but I will add in for your response questions that will be due with your homework. I'll probably just upload it separately. And then I might also just add in like example, whatever, extra practice problems so that you guys have more, like all my previous quizzes and stuff. So you have more ideas of what types of questions I ask. Okay. But I do want to encourage you to use your recitation packets as something to prepare for your free response. That is, when I'm writing free response questions, I look at old quizzes, I look at recitation questions, I think about what we've gone over, I think about maybe what you didn't show great mastery of on the quiz, and I sometimes revisit those. Sometimes I'll tell you in class, even on this exam, I was like, know these concepts, that's what I'm testing you over. So and it's not just going to always look exactly maybe like the questions you've had before, but if you have a thorough understanding, you should be able to get a significant amount of partial credit. Does that help? Do you feel more prepared for your next exam after this conversation? You feel like you know how to prepare more? Okay, the other thing I thought about doing was opening up like a discussion forum where you could be like, here's all my best test taking tips. This is what I did to study and prepare. Would that help you? Would you guys actually use it? Do y'all already have a group me? Yeah, use your group me to tell each other how you study. Say, hey, let's start, I don't know if it's a group me or Discord. If it was a Discord, let's start a thread where we just do our study taking techniques or all that stuff, you know. Also, just for future reference, when you have a group me, it's really stupid to put evidence of yourself cheating in a group me where anyone that you don't know very well could take a screenshot of it and send it to a professor, who is then required by the university to report academic dishonesty. So if you're gonna cheat, which it makes me mad when students cheat because I put so much work in, but if you're gonna cheat, be smart, not stupid. Okay. I'm gonna see if I can save this. I don't know. I'll just actually probably look it up. Okay, I have this recorded, so I'll probably just take this and upload it as test tips for y'all. Okay, great. So I wanted to start with that today because I guess I was when I read y'all's responses, I was like, oh, I'm kind of sad about this feedback, and I want them to feel more prepared for their exams. I don't want them to feel shocked. Yes. Oh, yeah. She can come in, yeah. I didn't want her to see the exam. She's standing outside.
Yeah, she asked me when I was.
You sure don't want that. Okay. Thanks for calling that out. Okay, so let's talk about chapter 5 before we do our class break and switch gears. Are there big concepts after the exam? Don't ask any specific exam questions because not everyone in this room has taken it. But are there concepts on the chapter 5 material that you want me to review kind of quickly or show you how I would do something like that? Before we move back into chapter 6, because you will need to be able to do Newman projections in chapter 7 and use them well and be able to rotate them. These things are going to come back up. I test you over things that are going to come back up usually.
If a question doesn't specify what carbon and carbon bond, to look through, do you just always assume like the second or third, like the second carbon or third, what you do next?
I try to always specify, but if it doesn't, you can either, if it's multiple choice, you can look at the answers and see which ones that are giving you that are like what it's through. Or if it's a wedge dash, you can be like, which ones have the wedges and dashes? Those are probably the ones they want to ask their questions on. But if it's a question from me on a quiz or an exam and you're not sure, you can just ask. You can always ask which one I meant. Because unfortunately, with my lack of dopamine at times, it's really hard for me to make sure that I've thought of every detail as I'm writing test questions. Okay, anything else from that chapter? From the chapter 5 specifically? Yeah. Wedge dash to what? Like Fisher? Converting to wedge dash from Fisher or Newman? Fisher, okay. So this is our Fisher projection. And I'll do chlorine, bromine, hydrogen, alcohol, bromine, carbon. I don't know why. I think all my fancy pens are dying. I need to buy more pens for my Rocketbook. Okay. So what is Fisher projection showing you? Can someone describe to me what Fisher projection shows you? Yeah.
Basically, it's just like
Vertical lines are going away from you and the horizontal lines are going towards you. So I'm gonna draw that out. I'm gonna build that out so that you can see how I would do it. And then I'll do it from, I guess I can do it from just the paper first, but I'll build it out for you. Alcohol. Here we are. And this one's okay, so if I had a structure like this, I would know it would be. I'm mad that these pins are dying. It would be bromine, hydrogen, this chlorine's going away. This is in the plane of the page. This carbon's going away. Bromine's coming towards me, alcohol is coming towards me. So if I were to imagine this like a Newman projection, these are eclipsed, right? The wedges and the dashes are both lined up. So I first kind of think about that, like, oh, it's eclipsed. So normally we see things represented in staggered conformation when they're in bond line formula. But this is actually represented in this formula, right? This is basically what a Newman projection looks like, only you're like on top of a Newman projection here. Okay, so if I am converting this to this, I start with my backbone. This chlorine is going away from me. This CH3 is going away from me. And then this is a carbon and this is a carbon. So that's my backbone. And then the hydrogens have to be on the same side. And I just sort of like imagine I move it this way and I'm standing here looking at it. So I just kind of rotate myself to get it in line with this. So the one on the left side, I imagine, is coming towards me. Like if both of these were coming at me and then I rotate it, one will be coming at me, one will be going away from me, right? So I make these two on the left come at me and these two on the right go away from me. So that's how I would get from Fisher to bond line. And if you want it in your traditional bond line formula where it's like up, down, up, down, up, down, you know, then you have to rotate it. So chlorine, hydrogen, bromine. Then you're taking these two that are pointing up. So this is your alcohol, this is your bromine. They rotate. So your bromine's pointing towards you and your alcohol is going into the page. This is sometimes called sawhorse notation because it looks like those things that people use in garages. Okay, so I'm gonna show you on here just so you can kind of believe me that that works. So you've got your chlorine coming away from you, your hydrogen and bromine towards you, your alcohol and bromine towards you, and then your CH3 away. So the first thing I did was swap it like this. So my hydrogen and my alcohol were coming towards me. That's the structure right here. Chlorine and CH3 in the plane of the page, and then your two bromines going away. And then if you want to convert it even further to the up, down, up, down type of thing, now your bromine's coming towards you and this bromine's going away from you. That's this drawing. So you should be able to kind of interconvert between these. You should even be able to go from, I probably wouldn't ask you to do this because it'd be a lot of steps, but from this to this to this eclipsed conformation, right? This is basically another view of a Fisher projection. Fisher projection here, Newman projection here, bond line formula here, a different bond line formula here, a different Fisher representation here, yeah. Okay. Yes.
For the Fisher projection, how do you know how many like carbons are? That might be a stupid question, but I have to look at the Fisher projection and then name them all based off of that.
Yeah.
How do I know that?
Let's do that. So this is a carbon right here because it's a joint, you know, like just like on our bond line. And then this is a carbon here, and my pen died, but this is also a carbon. I gave up. So how many carbons is that? So what's that called? Propane, because it's the carbon backbone is the parent chain. Okay, and then you kind of have to use regular nomenclature things. So you could either start from this side or this side. So there's only one high priority group there. It's the alcohol. The alcohol is 2 either way, right? If I number it from up, down, or down, up. So no matter what, it'll be 2OL. So then we'll just start with trying to get everything else to have the lowest numbers. So if we start from this way, chlorine and bromine here will be 1. And this, if we start from this way, chlorine and bromine there would be 3. So we'll start from 1, 2, 3. So looks like I have 1 chloro, 1 bromo, and then I'm like, oh, there's another bromo, 2 bromo, and then the alcohol, but I already accounted for that. So I think those are all my substituents. Did I miss any? No, okay. So then I combine this all in order. I'm gonna actually scooch down here to do it. So bromine comes before chlorine. So I'm going to do that first. There's 2 of them. So I'll say 1,2 dibromo, 1 chloro, propan, 2 all. Or you could do 2 propanol. And then just to make sure, I'm going to number it from here. 1, 2, 3. Oh, I'll just draw it back out. 1, 2, 3. 1, 2, 3. Nope, it's the other way. 1, 2, 3. 1, 2 dibromo. So we have a bromine here. Oh, that was a dash on this one. I didn't give you the RS configuration, so for right now we won't do that. So I have a bromine here and a hydrogen here. And then I also have a chloro on this one. And then I also have a 2 bromo. And then 2 OL. And then that's just CH3. So the base name is right. But we do have, it looks like 2 chiral centers to me. So then you would need to assign R and S configuration. So let's do that. So on this one, I'm going to use the Fisher projection because I think that's the easiest way to do R and S. What's the highest priority? Bromine. And then what's next? And then this chain is going to be 3 because there's a carbon right there, right? 1, 2, 3. So that's S, but is the hydrogen pointing towards us or away from us? Towards us, so it's actually R. Okay, and then on the bottom, same kind of thing. Bromine is 1. Between carbon and alcohol, alcohol is 2, and then 3. 1, 2, 3, and so that's R. Is the lowest priority group pointing towards us or away from us? Is that hard to see? It's this one. It's the same thing here. So I labeled 1, 2, 3. What's the lowest priority group there? No hydrogen. CH3. So CH3 is pointing away from us. So I can do 1, 2, 3. And that's R, and we can keep it R. So this would be 1R, 2R dash 1, 2 dibromo, whatever. So that's how you would go from Fisher to bond line. You could even go one step further to Newman, and you can name from that configuration as well. And then if I'm ever worried, maybe this is another test taking technique I can share. I'll reverse the question. So on that, I won't say which one, but on the test question where, I won't say it. But a lot of times you saw me in videos working a question one way and then being like, Was that right? I'm gonna work it backwards to check. So just like I did here where I wrote the name and then I drew it out. And that's when I realized I didn't have RNS configuration and I needed it. And I was like, oh, I'm glad I did that because now we can go over RNS configuration, right? So working from our answer backwards is a way to check yourself too. And it's a way to get extra practice on your practice problem. So like if you have a nomenclature question and it's what's the name of the structure and you write the name to check yourself, then draw the structure and then you're pretty sure you're right. And then you also got practice going from the name to the structure and vice versa. So I do want you to do some of those things because I'm not going to be able to give you every single thing you need to work on, right? So I want you to be able to go back and forth between two things, even if I didn't give you a question just like that. Okay, what else? Yeah. It's the number of the carbon in the same way you do your substituents, right? So if it's like, this was 1, 2, 3 because of our nomenclature rules. So 1 was R and 2 was R. So you just do the same as the same way you name a substituent, you're just naming stereochemistry. Any other chapter 5 questions? Okay. How are you feeling? Okay. I'm gonna do a video where I work the test. It should be up today or tomorrow, definitely before your next exam. And I am going to do some of those changes we talked about. I will, I know not everyone's in class today, so I'm going to post an announcement that basically says what we decided about adding free response questions to the homework and that kind of thing. Okay. Yeah. The quiz for this week is because I'm doing this instead, it will be online and it will be due whenever I said in my announcement. And then next week's quiz, that's your last quiz, and I'm gonna leave it the same. I think that that's the least chaotic. I'll leave next week's quiz exactly the same as it has been. It'll be in person. It'll be free response questions. It's only going to test what we've covered up to that point, but then you'll get tested over free response questions again when you have to turn in your homework. And I'll grade those. They will be graded. Okay. Great. Let's take our class break. I'm only going to give like probably about 3 minutes. If you could be back here at 12:10. And then we can dive into SN 2 and 1 reactions again. My brain is tired. Oh, my Adderall at home. Second half of class is going to be really hard. Okay. Let's start with chapter 6, substitution reactions. It's 12:10. Maybe I should give 30 more seconds for people to come back from the bathroom, etc. The vibe in here is like so quiet today. Are you all exhausted? Me too. If this was a normal semester, I'd be like, let's just end class early. But there's no time for us to catch up, sadly. Bummer. Okay. Maybe we can end a little early. My brain is tired. I feel like doing the work of thinking through what the best way to move forward is pretty mentally exhausting. So I think we're maybe all kind of feeling that. Okay. So what do you remember that we learned about substitution and no, we only did substitution reactions. What do you remember? The bar stool analogy. I see you. What were you gonna say? That's kind of the same idea, the bar stool analogy, and then there's SN1 and SN2. So tell me about it. What does the bar stool analogy mean for SN1 and SN2? Ugh, all these pens are dying. It's gonna be writing in red. Nucleophile pushes the leaving group off and takes their spot. That kind of gives a good overall idea of what happens in substitution reactions overall. What is the main overall reaction? Something is swapped out for something else. So if you're not sure on the substitution reaction, at least you can know that one thing is going to swap out for something else. Okay, so nucleophile pushes the leaving group off and takes their spot. What else happens in an SN2 reaction? Stereochemistry is inverted. What else? Okay, what about SN1? SN1 is in 2 steps. What happens there? What's happening? Okay, it's in 2 steps. What are those steps? Does the weak nucleophile push the leaving group off? The leaving group leaves, and then the weak nucleophile comes in. Great. Okay, can you think of anything else that we learned? Yeah. When the leaving group leaves, there is a carbocation intermediate. We haven't gone deep into SN1 yet, but that is true. What about the rate? Why is it called SN2 and SN1? SN2 is a second order reaction. And what does a second order reaction actually mean? It's bimolecular, but what does that mean? Yes, the rate is dependent on the concentration of both the nucleophile and the substrate. And can anyone explain to me why the rate is dependent on both of those things? I saw somebody's hand, I thought, maybe not. Say that again? Yes, that's definitely true. The rate is dependent on the rate is dependent on how quickly the nucleophile can swap out for the substrate. And how does that happen in an SN2 reaction? How does the nucleophile get swapped out for the substrate? No. How does the nucleophile get swapped out for the leaving group? It pushes it out the back. So how many different molecules are at play? 2. So the rate is dependent on the nucleophile and the substrate because both the nucleophile and the substrate have to be involved in the process of the leaving group leaving and the nucleophile attacking. So both of them are part of the process that's called the rate determining step. Both the nucleophile and the substrate are part of the hardest energetic step that takes the longest to accomplish. So if you have more of them, there's a higher likelihood of that happening, and so the rate increases, and that's why the concentration is dependent on the rate of both of those. I could see myself asking you a question where I want you to explain why, or what it actually means that the rate is dependent on both of these things. One of those causal relationship type questions. Okay. Not for sure, but I could see myself doing it. Okay. What else did we learn? Yes, for SN1, I don't even know if we did our deep dive on this yet, but yeah, rate is equal to just the substrate. And why is that? Yeah, it's one what? It's one molecule that's involved in the hardest part, in the most energetically unfavorable part, which is the leaving group leaving and having a carbocation left behind. Okay, I think we are missing one other thing that we talked about, which was what is this? Reaction coordinate diagram. Okay. So the energy, it's also called the free energy diagram. It tells us what the difference in the Gibbs free energy is in the products and the reactants. What goes here? Reactants. What goes here? And what goes up here at the top? Transition state. So that's something else we learned about that we did not talk about. It's often denoted like this. It looks like a T with 2 crosses inside of brackets. What is the transition state for an SN2 reaction? To what? That's for an SN1. Did I say SN1? Oh, okay. I want to know, I don't know what I just said, so I'm going to say it again. I want to know what the transition state is for an SN2 reaction. What's actually happening right here? Yeah.
And the attacking molecule is the backside, and they're both somewhat not attached, but near.
Yes, exactly. So, and I didn't get a chance to show you what this looked like yesterday, and I'm going to show you now. Did I leave this upstairs? No, I did. Oh, this is so sad. There's only one atom in this whole set that can do it. On my left, I think that one atom upstairs. Oh, well, I guess I'll use this one. Okay, so let's imagine a tetrahedral molecule. It's going to not look perfectly tetrahedral initially, but we'll imagine it. Okay, so this is our tetrahedral molecule. And imagine it has the leaving group right here. Okay, so you can kind of see how this is tetrahedral, right? Okay, this is our tetrahedral molecule. It looks like this. I left that one that works upstairs. I'm sad about it. Okay, and now we'll have our attacking group come in. And as the attacking group comes in, the electron density starts to be pushed here. Does that make sense? So what is this shape called? Trigonal bipyramidal. This is the transition state. This is coming in and this is leaving. Then this leaves fully, this fully binds, and that's why our stereochemistry is inverted. Because now it's back to just a tetrahedron. Okay, So what the transition state is really, that's the rate determining step, kind of, like, it's the actual action of what's happening on the rate determining step. That's why it's the highest energy there. That's the hardest thing to happen. Two big electron clouds don't want to be near each other. I want you to be able to draw a transition state. So you can have just whatever your R's are here. So we're imagining that this is the plane of the page. One is coming out at us, one is going in. You don't need to specify that, but I kind of want you to know this, the R's are the plane of the page, and then the leaving group's coming, or the leaving group's leaving while the attacking group is coming. Transition state. So I'm going to put nucleophile on one side, leaving group on the other. This is a transition state, and I want you to be able to draw it, and you throw it in brackets, and you put this that little symbol goes up in the corner. And that's how you know this isn't something that, it's not an intermediate, it doesn't stop. You can't like freeze a molecule at this point. And once it started to happen, it's happening like a roller coaster. You can't like take it out and put it in the bottle at this point. You can do that with intermediates. So you can't ever freeze this. We just know that it's happening, and this is a representation of why there's a high energy peak right here. Okay. Okay, so I think that's pretty much everything we learned about SN2, and we just touched on SN1. Okay, we had our, we've been going through our outline, right? So we did the overall reaction, and then we talked about the anatomy of the substitution reaction. So you knew the language of a nucleophile, an attacking group, the substrate, the leaving group, all that stuff, and what all it needed. We talked about how sp2 hybridized bonds cannot undergo substitution reactions. We talked about good nucleophiles need lone pairs to act as basically a Lewis acid. Strong nucleophiles are usually negative. Weak nucleophiles are usually neutral. We assume no solvent effects, which we'll talk about later. And then we did a deep dive into, oh wait, maybe this is the mechanism of both. Yeah, okay, and then we did a deep dive into SN2. We talked about the stereochemistry as a result of the backside effect, attack. We talked about the kinetics, why it's called SN2 and what affects the rate. And then we did the reaction coordinate diagram, right? Okay, so we did all these visualizations. And we talked about bimolecular reaction, and we did the reaction coordinate diagram, and you should be able to label all these parts. And then I think we stopped right here. So things that change the rate is the concentration of the nucleophile. The reactivity of the nucleophile also will change the rate. So if you have a stronger or more nucleophilic nucleophile, that reaction will go faster. It's not like oh, this one increases it by this percentage. You don't need to know that. You just need to, like, if you're comparing two nucleophiles, which one of these is better? That kind of thing. You need to be responsible for that. We'll do practice problems like that. The structure of the substrate also impacts it. So if the rate is dependent on the nucleophile and the substrate concentration, it's also dependent on the nucleophile and substrate's properties. So if you have a stronger nucleophile, that's going to go faster than if you have a weaker nucleophile. And if you have a leaving group that's really easy to access, like a primary alkyl halide versus a tertiary alkyl halide, it'll be much easier for the electrons of the attacking group to get in on the primary than the tertiary. Tertiary is a lot bulkier, right? So not only does the concentration matter, but the properties of the substrate and the nucleophile matter. And you won't have to do like the math type thing with the substrate and nucleophile properties. Like if you double this, the rate is doubled, that's concentration. You just need to be able to compare to and say, this one's better. If I had to pick which one I'm doing, this one would go faster, this is better, this is more energetically favored. That's kind of what I want you to know about that. And then there's also solvent effects. Solvent effects matter, but students worry about them a lot, and they don't need to be worried about a lot. So I'm leaving that for last in the this part. So don't worry about solvent effects yet. Okay, so nucleophile strength impacts the rate. So the identity of the nucleophile matters. how strong the nucleophile is. This is also called nucleophilicity. And I hate this measure, but it's measured in terms of how quickly it will react in an SN2 reaction, which is so annoying because my question to you is which one of these will act faster? And the answer is like, oh, the more nucleophilic one, which is the one that reacts faster. It's so annoying. And I spent like years trying to figure that out. And then I kind of had a breakthrough, which was reading this chapter this section straight out of Solomon's book. So nucleophilicity, it's not the same thing as basicity. That cleared a lot of things up for me. Nucleophilicity is measured by how fast does this react in an SN2 reaction or substitution reaction. Basicity is all about protons, right? So they're two different things. Sometimes they're used interchangeably, but that's not really correct. I probably even use them interchangeably sometimes in videos, but that's not super correct. So here are things that can change the way a nucleophile is stronger or weaker. So a negatively charged nucleophile is always going to be more nucleophilic than its conjugate acid. At this point, we're not assuming any solvent effects. We're not thinking about solvent at all. But if you have like OH minus versus ROH, OH minus is always going to be better than ROH or OR minus. The negative will always be a stronger nucleophile than the neutral. And that's actually why I have the categories in my mind of strong nucleophiles usually negative, weak nucleophiles are usually neutral. The other thing is, this is helpful for when you're answering practice problems. If the nucleophilic atom is the same for all the things you're comparing, then it does parallel the basicity. So there's a practice problem on your homework. We talked about this in office hours today. It was all sulfurs. And so you needed to figure out why or which one would be the most or least nucleophilic. You could basically just think of it in terms of acidity and basicity because all of that nucleophilic atom is the same. So in this case, OR is more basic than OH minus, is more basic than a deprotonated carboxylic acid. And all of those that have negative charges are more basic than alcohol and water, right? So this parallels the basicity. It's also the nucleophilicity. And then if the nucleophilic atoms are different, that's not always true, and especially in protic solvents, things will change. So protic and aprotic solvents mean is there a hydrogen present or not? Proton, protic, hydrogen present. And usually that hydrogen is available for hydrogen bonding intermolecular forces or dipole-dipole intermolecular forces, depending on what it's bonded to. And that will impact it, but we'll talk about that last. Okay, structure of substrate also impacts the rate. So for an SN2 reaction, you want something that's not sterically hindered, that's not bulky, there's not a bunch of crap around it because the nucleophile needs to get in there and kick something else out, right? So you don't want something that has a lot of crap around it. Primary substrates, primary leaving groups are the best for SN2 reactions. Well, methyl's even better. I guess that's still technically primary, but so if it's just a carbon with hydrogens around it, that's the best. And then if it's one carbon with another carbon, and then secondary, tertiary, all of that. So the less sterically hindered, the better for an SN2 reaction because an SN2 reaction is trying to come in and kick something else out. So the nucleophile needs a clear path to be able to get in and then kick out the leaving group. And then we already talked about that really tertiary doesn't undergo SN2 reactions hardly ever, but neither do vinyl or aryl halides or anything directly bonded to an SN2 or a sp2 hybridized carbon. So tertiary not happening because there's so much stuff blocking that nucleophile from getting in on the backside that it literally can't. I like this visual. It's like tries to go in and all those electrons repel it away. Okay, so and then this is just it's just kind of trying to show you, but you don't need to memorize this and you don't need to know the ratio of like primary, secondary, tertiary. You don't need to know the math to it. I just want you to know that, see how much more quickly the speed of this is, it's 2 times 10 to the 6. I was trying to do that in my head real quick. Is that 2 million? Yeah, I think so. This is 2 million and this is less than 1. It's significantly different. And actually, if you're taking ochem 2 here, you'll get to do substitution reactions where you have a primary, secondary, tertiary, like bromo, whatever, and you add a sulfin that will do a substitution reaction, and you can see with your own eyes that the primary and the methyl like react really quickly, and then the other one, like the secondary, like slowly starts to come around, and then the tertiary usually never reacts unless it's been contaminated, which a lot of times students aren't careful and it gets contaminated. So that's kind of a bummer. But you can, that's one of my favorite labs because you can literally see the SN2 reaction come to life in front of you. And then this is just another representation. If it's all hydrogens, it's not very bulky, so it's easy to get in there. But if there's all kinds of bulkiness around it, it's very hard to get in. Even if it's a tert-butyl that's 1 carbon away, it's still very hard to get in. So you have to think about the actual sterics of the reaction and not just, you can't just memorize primary, secondary, tertiary always, because a tert-butyl that's 1 away is still going to be really bulky and blocky. And again, no SN2 reaction on sp2 or sp hybridized carbons. Okay, and then the leaving group also impacts the rates. So leaving groups depart with the electron pair that was used to bond them to the substrate, right? And they end up being the anion of that. So if you have like a chlorine and it leaves, it becomes Cl-. The best leaving groups will become pretty stable when they leave. So anything that can better stabilize a negative charge is better. So something that you tend to think of as being very reactive in its negative state, like hydroxide, is something that we see a lot attacking other things. If it likes to attack other things, it's very reactive, it's not stable. So it's not a good leaving group. Okay. So good leaving groups are stable after they've left. It's kind of like when you send a kid out to college who's like pretty even keel and stable and good with their finances, and they go to college and everything's fine. Or there's a kid who goes off to college that doesn't know how to spend money, and they kind of are like manic in their spending, and they spend a lot and then they're broke, and then they spend a lot and then they're broke, and they go off to college and it's not great. You want to send the one off to be completely independent that is capable of handling the extra burden. Same thing is true in leaving groups. You want a leaving group that is capable of handling the extra burden. Okay, so we want to look at the stability of what's left. And fluorine's not super stable because it's so small, but these were pretty good leaving groups. Tosyl, we'll talk about this later. It's just like a special leaving group. I don't like to make my students learn about it until we get into chapter 10, more on alcohols, but they, a lot of times, because OH is a bad leaving group because it becomes OH minus, you can swap it out for this thing called a tosyl, which is just like a good leaving group, but you don't need to really memorize that yet, just so you can know that it exists. Okay, so normally these don't undergo SN2 reactions. You can convert them to good leaving groups by protonating them first. I don't know why that just popped up at the end, but we already talked about it. Okay, so my dad's calling me. That's cute. So my dad just retired. He has so much free time. He loves to call me now. If you have a bad nucleophile that's going to be a strong basic anion, that won't be great. But if you protonate this alcohol, then if it leaves its water, water is very stable, right? It's a very weak base. It's not very reactive. So protonated alcohol is a good leaving group. And then these are the tosyl ions I was talking about. Whenever I see this, I just like scratch it out and write good LG, right? So you don't have to memorize that whole thing, but tosyl, or sometimes it's called mesyl, these things are good leaving groups. And so they oftentimes they're easy to convert alcohol into. Can you think about, I won't say it's easy to convert alcohol into these groups, but can you see why this group would be a better leaving group than an alcohol? Like just look at maybe this one. This toluene, also called tosyl. Resonance what? Resonance can stabilize the negative charge. If this negative charge was on this sulfur, this tosyl group, it could go here and kick one of these oxygens up. It also could go here and could kick one of these oxygens up. So that already splits it between 3 oxygens instead of just 1. And I think there's even a structure then where after you've kicked this here and you kick this one up, there can be a bond between this sulfur, a double bond between the sulfur and carbon, and then the negative charge will move here and it'll go all the way around the ring, I think. So there's like 6 different resonance structures, I think, for this. So imagine 1 negative charge on OH minus versus 1 negative charge spread out on 6 different structures, or even just 3 different structures. It's a lot better. It's a lot less negativity in one area. So that's why these are good leaving groups. They can stabilize that negative charge. Okay, so this is just showing you again. If it's a strong acid, it'll be a weak base, and weak bases are usually good leaving groups for the most part. And then again, strong acid, good leaving groups, weak acid, bad leaving groups. I don't want you to memorize this. I don't think it's helpful for you to memorize, like, oh, these are some good ones, these are some bad ones. I want you to be able to use your brain and think through, like, oh, this is a good leaving group because it can stabilize this negative charge. Or this is a bad leaving group because it really is going to want to react. We use this as a base pretty regularly. It's reactive. It wants to steal things. It wants to get a proton. This is not a good leaving group. I want you to be able to think through those things. Okay. So that's our deep dive into SN2. When we do our recitation tomorrow, you will have to draw an overview of an SN2 mechanism, and you'll need to be able to label all the parts on it. You'll need to know what the transition state looks like. You'll need to be able to label that on an energy diagram. You're responsible for all of this for the recitation and also for your quiz. That's not tomorrow, but you will need to know all of it. Okay, we're gonna power through. We can do it. We're gonna just start SN2. I really want to quit now, but we won't. We're gonna power through. Okay, SN2 reactor, SN1 reactions are 2 separate steps. The first step is that the leaving group leaves, leaving behind a carbocation. So I want you to think about that. What is the hybridization of a carbocation? sp2. What's the shape of an sp2 hybridized carbon? Trigonoplanar. Okay, so the leaving group leaves, and then you have this flat carbocation. Where do you think the nucleophile is going to attack? What? It attacks the carbon. Does it attack from the top or the bottom? What? Why the bottom? It does not matter. It could go from either side. It's equally sterically hindered here or there, and from both sides is pretty clear. So what do you think that means for if there's a chiral center that undergoes an SN1 reaction? What do you think the resulting stereochemistry would be? A racemic mixture. You'll get both R and S configuration. So what's the stereochemistry change in an SN2? It's inverted. You go from S to R or R to S, assuming that the priority of the substituted groups are the same. The stereochemistry for SN1 is 50-50 R and S. Racemic mixture. So the leaving group leaves, you get your carbocation, and then your nucleophile will attack. Now, usually for SN2 reactions, you have weak nucleophiles. So when a weak nucleophile that's neutral attacks, it suddenly is usually positively charged. So sometimes included as a step in SN1, but not always, is the deprotonation of your substituted group. So the water or whatever your solvent is comes and takes this hydrogen so that you end up with just an alcohol swapped out. I think it can be kind of confusing to think of this as a separate third step because we talk about SN1 reactions being a 2-step reaction. And sometimes even this third step isn't drawn on energy diagrams. Sometimes it is and sometimes it isn't. And that's because I think you'll learn as we go through, even into ochem 2, deprotonation is something that is almost seen as happening very rapidly in organic chemistry, and organic chemists are like, and then it just gets deprotonated, and they're like, it just happens, and we don't talk about it. So sometimes it will be explicitly stated, and sometimes it won't. While you're learning, I want you to explicitly state it, because it will help you to learn, like, oh, and then it gets deprotonated. You don't need to always know exactly what deprotonates it. You can usually say the solvent will deprotonate it. So if it's in water, if it's in alcohol, it will get deprotonated, because really it's in an equilibrium, right? That proton is being shifted back and forth, back and forth. And then in the lab, what we as organic chemists do would actually add a little bit of base to this to neutralize it, so that there's no extra positive charge in there. So you could even just put base, comes and takes that proton and gets rid of it. Doesn't matter what deprotonates, but it needs to be deprotonated to get to your final answer, and you need to say that it gets deprotonated for this stage in your learning process. Okay. So the stereochemistry of an SN1 we talked about, it's a planar carbocation, and so there's only 6 electrons in the valence, so it really wants something to come and react with it. That p orbital is empty, so it'll come in and attack and convert it back to an sp3 hybrid, and it can be a racemic mixture 50-50 RNS. So this is just going to show you an example. The transition state, I don't like that it's drawn like this. This isn't a transition state. This is an intermediate. This is not a transition state. I don't like these brackets. So this, you could bottle up a carbocation and put it on a shelf. It's not very stable. It'll react as soon as it can, but you can bottle up a carbocation and put it on a shelf. People do it. You can't really sell it, but you can save it and work with it again later. And you can even sometimes take images of it, like on in certain instruments. But the transition state would actually just be a dotted line with the bromine leaving. That would be your transition state. And then maybe a partial positive on your carbon. So your alcohol can attack from your left or from your right, 50-50 chance of an RNS racemic mixture. Okay, the slowest step is that leaving group leaving. And then everything that happens after that happens really quickly. So we only talk about the rate determining step as the leaving group leaving and making that carbocation, because that's hard to do. I hate that. Okay, so this step is so much slower than these other two that they don't really matter in the rate at all of the reaction. And in SN2, everything happens in one step, so we don't have to think about what comes next at all. But in this step, we have the leaving group leaving. This is the big rate determining step. The nucleophile attacking happens so fast because the positive charge really wants to react with something. And then the deprotonation will happen relatively quickly as well. So again, the rate of the SN1 reaction, we already talked about this, depends only on the substituent. So this is a first order reaction, so it's unimolecular, and that's why we call it an SN1. Substitution, nucleophilic, one molecule is involved in the rate determining step. One molecule is involved in that transition state that's hard to accomplish. I already told you what the transition state was, so sorry about that. So this one does have all three steps involved. The main two steps are step 1 and step 2, and then this is just the deprotonation that you need to know about that at this stage. You need to talk about it. So the products react, and then the transition state here is just a dotted line with the bromine leaving. Then you get your intermediate where you can bottle this up, but it's not very stable. And then the next transition state is just a dotted line with the water attacking. So the bond starting to form. And then the next transition state is the proton leaving. You don't need to be able to draw that. So the proton leaves, and then you get your final product. So for SN2 reactions, the concentration and reactivity of the nucleophile matter. So you had to look at nucleophilic strength, right? This is just all the things for SN2 that we had. So for SN1, we don't worry about that. It does not matter. We don't worry at all about the nucleophile, about the nucleophilicity. It doesn't matter. So what we do care about is the structure of the substrate and the stability of the carbocation. And we care about the effect of the solvent, but we're going to talk about that last in the context of SN1 and SN2. So we're not going to do that on our deep dive. So carbocations, what do you think could improve the stability of a carbocation? How substituted is? Do you think more substituted or less substituted is better? More substituted. Why do you think more substituted makes a carbocation more stable? That's right. There's more electron density to offer some electrons to stabilize that positive charge. So it's basically the inductive effect, but kind of reversed. So when we were doing acids and they lost a proton, we wanted the inductive effect to pull electrons away. In this case, if we lose the leaving group, it's positively charged. We want inductive effect to donate electrons. So like carbons have electrons to donate, whereas hydrogens don't really have electrons to donate. So if you have a carbon with 3 hydrogens and that's positively charged, that's going to be a lot more reactive than a carbon with 3 carbons around it. What else do you think could stabilize a carbocation? Actually, a positive charge being right on an alkene is less stable. So is that what you mean, or do you mean something else? If there's a double bond 1 carbon away, or even multiple double bonds, it's capable of resonance. That's what I was looking for, resonance stabilization. So if you have a carbocation that is stabilized by resonance, that is better than a carbocation that's not. So in this case, the nucleophile doesn't participate in the rate determining step. We don't care about it. It's not affected by it, but the structure of the substrate does matter. So for an SN1 reaction, more substituted is better than less substituted. So these basically don't react at all. The primary and methyl don't really react in an SN2 at all because it's not stabilized enough. And the more stable it is, the more quickly the reaction will go. This picture down at the bottom just shows you why, like how the inductive effect works, how those electrons are literally like being sort of shared into that empty orbital, whereas hydrogens wouldn't be able to do that. And this also shows you the arrows of the inductive effect. If there's 3 carbons, they could donate more. If there's no carbons, they can't donate at all. And then there's also resonance stabilization. If there's a double bond 1 away, that's called allylic. I don't know why, that's just what it's called. And then if it's 1 away from a benzene ring, that's called benzylic. And those are like the creme de la creme. They're very stabilized, especially resonance, or especially benzene, because the positive charge, instead of just being in one place, can be stabilized all around. So in general, this is more stable, this is less stable. I think I was just summing all these up. Oh, I think I was going to delete all those other slides, and I never did. So these are not vinylic. These are allylic and benzylic. So these do undergo SN1 reactions because that bromine is attached to an sp3 hybridized, and then it's stabilized by resonance. If it was right here, resonance stabilization wouldn't really work. So that's why benzylic and allylic are good, but vinylic is not good. It's an sp3 hybridized carbon still. Okay, this just shows you the structures and how it stabilizes. Okay, so what we're going to do tomorrow is we'll finish solvent effects out for both of these. That's the last little bit for substitution. And then we'll talk about one more weird thing that carbocations can sometimes do, and then we're going to dive into elimination reactions. I still don't want you to worry about telling if it is going to be a substitution or elimination. But I do want you to start thinking about the difference between substitutions. If there's a strong nucleophile, what does it favor? If there's a weak nucleophile, what does it favor? If there's a tertiary leaving group, what does it favor? Tertiary leaving group, what does it favor? SN1. If there's a primary leaving group, what does it favor? Okay, start thinking about that when you're trying to tell the difference between what substitution reaction might take place.